Alright, this part of our physics lesson is going to be pretty cool because we're going to start creating active physics. And active physics creates movement based on forces. And we can do all kinds of cool stuff with this. So you'll see here, we've gone through the passive physics, right? We create a barrier. We create just basically a wall. So if I click on my play button here, I've got my script controlling this guy, and I can't move through these cubes because I have colliders on them. And he, of course, has the rigid body, which we're going to explore in a second. Alright, and I can't move through the wall. Now, this script and this particular file here that you'll find, it's physics lesson 503 here. It also has a piece where if I push the space bar up, he actually floats over the wall. So if you need to get over those walls, you can hit that space bar and it will float him up. Now what happens when I let go of the spacebar? He falls down. We're going to show you how to do that in just a second. But for now, let's just see. Okay, well, my guy's running around. Can't move past his barriers. All right, so how do we turn what is a passive physics object into an active physics object? All right, well, it's fairly simple. Let's just grab one of my cubes here. All right, so you can see I've got a cube. It's got a collider, which is why my little iGuy character can't penetrate it, right? But when he hits it, it's like a wall. He can't move the object. So what if I want to interact with this object and have this object be moved around by my character when those two objects collide? Well, that is when I create some active physics. So all I have to do is give my cube here a rigid body. Let's go to Component, Physics, and Rigid Body. Alright, so what does that rigid body do? Well, the rigid body is there to control the transforms of this object. And let's just kind of look down here. We have a mass. I can change the relative mass of my object. And that's important because the heavier the object is, the harder it is to move, right? You ever try to pick up a car? I doubt you can do it. Why? Because it weighs too much. The mass is too great for you to pick up. So, if that car weighed 2 pounds, or if the mass was, a tenth of what it is, you might be able to pick up a car. So the whole idea is that mass creates impediment to moving an object. So if one object's mass is 1 and the other object's mass is 12, it's going to be a lot harder for the lighter object to move the heavier object. Conversely, if one object has a mass of 12 and the other object has a mass of 1, one's going to be much more dense than the other one. All right, and that mass is actually going to make a big difference in how your objects react to other physics and how they react to forces, which we're going to get into later, how we add forces. Alright, so this right here, this drag, drag is basically the reverse effect of a force. So if I'm adding a force, it's going to take a little bit of time to get moving, kind of like wind drag or water drag. And you can do this to simulate underwater physics or falling from the sky physics. There's a lot of things you can do with drag. The drag is basically the resistance, the pushback against whatever forces are affecting your object at the moment. An angular drag is the same thing, but it applies to rotation. So if you have something that's rolling, but you want it to look like it's rolling kind of slow or it's really hard to get rolling, you can add a little bit of angular drag. And the default is 0.05. I usually leave it there unless I have something really specific I'm trying to do. Alright, use gravity. What do we do with use gravity? Okay, use gravity basically just turns on the global gravitational force, which is technically set to realistic levels, although you can increase these in your physics settings. You can make gravity denser if you're on a different planet. You can change that dynamically if you have a character that's going into like a low grav area. And a lot of games do this. You go in somewhere and it's low grav, you can jump really high, and you kind of float up. We can change those parameters on the fly if need be. Alright, right now I'm going to leave this on. Now, is kinematic, what does that mean? Now, is kinematic means, is it a part of a chain, right? Is it being controlled by, let's say, a character skeleton? Or is it moving by itself? And what this means is that the position of this object is going to be controlled by the transforms, instead of the transforms controlled by the rigid body. And you may say, why do I need a rigid body in an object if someone's controlling it with the transforms? Well, the rigid body has to be there in order to affect other transforms. So this is really useful when you have a character who needs to beat stuff up with his fists or pound the wall into pieces. What you do is you make sure that this collision box or this rigid body is on collision sphere, which is an object on the guy's arm parented to it. And then it won't change the position of the hand, which is what you don't want, but it will affect the other rigid bodies in the scene. And this is pretty specific, and in that sense, I have a character, I need his limb or his body to affect other objects without being affected itself with the transforms. Alright, interpolation, these are some interpolation and collision detection. These are fairly sophisticated things that we change for very specific reasons to make the physics engine more accurate, which also increases the amount of resources that you need for it. So we can just leave these two for the default. Interpolate none, and collision detection should be discrete. Alright, constraints. This is actually pretty important because if I want to constrain an object in an axis of rotation or position, then I can. So I can say this object can move around, but it can't move up in space, or I can't rotate around one axis or at all. And so I do this a lot when I need to freeze an object's rotation, but I want it to move based on the rigid body. Right, so we've created the rigid body for this object. Now let's see how that rigid body is affected, or how it affects the transforms of that. So I'm going to hit play. I'm going to go over here to my passive collision box, right, and it's just not going to let me pass. It's still using passive collision. But now what happens if I hit my cube with the rigid body? And you see it start to move. Now notice this guy doesn't tump it over completely. Well, it's just an issue of mass. If I hit it hard enough and far enough away, I should start to tump it over. But you can see that I'm actually moving it. There we go. You can see that now it's being affected by the rigid body of the character. It's a really challenging game to knock this thing over. Alright, well, let's look at the masses. What's the mass of this object? 1, right? The rigid body of our eye guy is 1. The mass is. The rigid body of the cube is 1. Now, if I either make the mass of the cube lower or make the mass of my character higher, we should see him move it more. Right now, those masses are equal, so it's definitely moving, but it's not being knocked around. So if this was like something like a beach ball, right, where the mass is very low because it's basically a piece of plastic inflated with air, then let's do something like that. So I'm changing the mass of the cube to something very low. It should definitely move a little bit more. And since we're in, there we go. We can see it move a little bit more. I still see, there we go. There's a little bit more of some movement. So because that mass is lower, and I can make it even lower. If I want to make this 0.1, it should become even more susceptible to movement from my character. There we go. Now I tumped it over. Why? Because the mass is pretty low. Now, yes, can I make the mass of my character greater? Absolutely. Now, when you mess around with masses in physics, one of the things is you just have to kind of work on it to tweak it. And to get the combination of mass that you need. And see, because I made his mass heavier, it's going to move or push that object around a lot more. However, my script that I have that floats him upward isn't working anymore because his mass is too heavy for the force that I've created. So once again, the thing is that you have to spend a lot of time tweaking these parameters. There's no real-world equivalent. They seem to represent real-world values, but oftentimes the way they behave is not quite the same as the real world. So here's just a little bit of a lesson in active physics. We've created, right, and I can do the same thing over here. Once I create a rigid body, now it's an active physics, which means it's going to affect the transforms. So now I can move that object around. And I can even knock it over. So that is a good rundown of active physics. We create a rigid body for an object if we want it to move based on its physical interaction. Now, one last thing I'm going to show you here. And let's just grab this cube. I'm going to duplicate this cube here. The reason I'm going to do that is because I'm going to change a property that we haven't talked about yet, and it's called the physics material. So we really want to know what kind of physics material we have, because not all materials are the same. Concrete, rubber, wood, ice, all of these things are going to have completely different properties, right? And this is something we use for the ground a lot. If I need a bouncy ground, if I need a bouncy object, if I need to have ice where things slide across, I can change all those parameters, and it's called a physics material here. Now, I've created a physics material, if you look under physics, called rubber. And we can actually just drag and drop it onto our object, and it'll show up here under the collider. And that the physics material has specific properties. I'm going to put bounciness as high as it'll go, which is a 1. And I'm going to put static friction to a 0. And static friction is when it's sitting on the ground, how much does it grip the ground? Dynamic friction is how much does it stay on when it's hitting the object. And there's a whole lot of different things we can change. There's a lot of parameters, and there's some prefab dynamic materials, physics materials you can download. But right now that I put the physics material of rubber on the ground, I'm going to also put it on this object. If I hit play, you notice how the object's going to bounce. It's pretty bouncy, it's continuing to bounce. Now that object is a bouncy object, and the ground is now bouncy. So you can see, now of course it's not going to bounce if it doesn't have a good height to bounce from. But you can see, just from that sim, that physics material changed a whole lot about the properties of the interaction between these two dynamic physics objects. And of course you can get rid of all the friction if you want to slide. You can do a lot of different stuff with those physics materials. And it's important because, let's grab our cube here. If I choose none, then it'll be standard. It will bounce a lot less. It'll still bounce some because the ground is bouncy, but if I grab our ground and change that to none, then nothing will bounce at all. You see, it just stops and kind of gloms itself onto the surface. Why? Because we're not using a physics material that is giving it certain properties. And we can create a new one, and we can call that ice. And what kind of property is ice going to have? Well, it's not going to be very bouncy, is it? No. But it's also going to have no friction at all. And now it's not going to bounce, however, we should have, and one of the things I think I forgot to do here, that's right, I got to apply it. Always go back and double check when something doesn't work out quite the way you thought it was going to. Now, yeah, see how I'm sliding that thing all over the place? It's because there's no friction. Why is there no friction? It's ice. Now I can make my cube an ice cube. And that should give us even less resistance. There we go. Now see how I hit it and it keeps flying? There we go. Does that look like ice or what? Boom. See, it's going flying right off the edge. So you can see how that physics material changing the amount of friction. So I just push it and there it goes. I'm not even touching it. It just keeps flying right off the edge. Alright, so that physics material made a huge impact and difference in the reaction between this object and the object it's colliding with. Alright, so this is just kind of a good rundown on how to set up and manipulate and edit your dynamic physics to create the appearance and the game mechanics that you want.